This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
For Software Engineering Radio, this is Robert Blumen. I have with me Chris Love. Chris works at Modernize as a distinguished engineer. Chris and Jay Vyas are co-authors of the book Core Kubernetes, and Chris is a Google Cloud Certified Fellow. Chris, welcome to Software Engineering Radio.
Thank you, Robert. Really appreciate you having me come and speak with you folks today.
Happy to have you. We're going to take advantage of your being here to talk about Kubernetes security. Now, Kubernetes is a distributed system, accepts external traffic. It uses compute resources. Is there such a thing as Kubernetes security, or is it just about following best practices that are well known for these type of systems?
I think it's both. I think, of course, it's best practices like update your software dependencies, update your dependencies from your operating system. It's that, but now you're running a containerized system, so you have to remember to update the dependencies in the container as well as update your host version of Bash. So, of course, there's intricacies to it. We're running a nice distributed system that allows us to do complicated stuff like scaling, and we have failover. But because of that, we've got a little bit more complicated networking that can cause some challenges from a security standpoint. But we have other distributed systems that we've been using for a while. Most of them are based around containers, but there's definitely some wrinkles. But like you said, at the end of the day, it's an API layer. You've got a bunch of compute nodes, which are either your servers or your EC2 instances or your GKE instances. And you've got a bunch of containers running around. So I would say it's non-trivial, but it's not rocket science. It's not as challenging as catching a rocket with a couple chopsticks.
The overall umbrella of Kubernetes security, it has many subtopics, more than we could cover in an hour. If you were to pick a few that are most important to focus on, what's your short list?
I would try to group them into, I kind of go from a large world internal. So we could talk about what to expect when setting up a Kubernetes cluster. So overall security. Then you can go down to node level security. From there, network security. From there, pod security. And from there, container security. Container security is well documented, but I think some folks either don't have the time and money to put those in place. Operating system security, I'm not going to talk to you about. There's lots of other references that folks can go to that I always look at myself as a Lego engineer, right? We've got building blocks. Some are unique to Kubernetes. And like you said, some operating system security is operating system security. But typically on an operating system, you aren't running two different network layers. And that's what you get within Kubernetes.
So it'd be a good time for me to let the listeners know we did an entire episode on Kubernetes networking, number 619. We will return to that a little bit later. Let's go down your list, Chris, and hit these things in order, starting with setting up Kubernetes overall security. What are some of the main points that should be addressed?
Right. You want to think about from a network layer, from a node setup layer, and from an overall account permissions layer. Again, if you're running in a data center, this is a little bit different, right? But I would say majority of people that are running in Kubernetes are running within AWS or GKE or Azure or pick your cloud provider. So there's always some gotchas around those cloud environments. For instance, you want to make sure that the role that you're setting up your cluster with and the role that the cluster is running with are the correct roles. You don't want to set your cluster up with a role that is a account level admin. You want to give your Kubernetes cluster and your Kubernetes nodes the right level of permissions. So that means setting up a user before you set up Kubernetes. From there, also look at a private network. Don't expose your nodes to the public. In other words, port 22 on node A should not be accessible via an external network. You're going to need to VPN into your nodes. And realistically, developers and admins shouldn't necessarily have to at a node level. Also, your API layer, your web API, should also be behind a firewall. That should be networked in. It should be on a private network where folks aren't able to access it. And we've had bugs in Kubernetes where authentication for a very short amount of time was broken at the API layer. And fortunately, the folks that maintain Kubernetes fixed it pretty fast, but it was overnight where if you had a publicly exposed API and you had XYZ version of Kubernetes, people could just do a kube control command right to it. So doing some basic setup before you are thinking through your security model and your security setup before you set up a cluster is really important. IP spacing, for instance, that gets folks in trouble as well. So you want to make sure the subnet you're running on is private.
Main points there would be use the cloud service provider's access management, use a private VPC, and put your whole cluster behind some kind of firewall or proxy to cut it off from the web. Did I miss anything?
No, and then you're looking at some form of public ingress, right? You're looking at having to maintain some form of ingress controller that'll allow external traffic to go in internally into your cluster, which makes it a little bit more complicated, but I'd rather not have nodes exposed to the internet personally.
Would any of the last set of answers change if you are running the cluster on the company's own computers?
You can think about it in the same way, right? You would have some sort of router setup where you, again, have internal IP addresses and external IP addresses. It's just more work. You have to set up your air quote VPC network or network that's internal by hand and maintain it. And you can't just make a Terraform call to your cloud provider's API to set it up for you. You have to have yourself or somebody else set those routers up. But same type of model exists. Networking is networking. We have IP addresses here and there.
Do you have any stories from a time you were setting up a cluster, something you missed, or from auditing another setup where you found something that needed to be locked down?
Yeah, many of those. I've found pretty much everything that I've talked about set up incorrectly. A lot of the times people set up their cluster and expose the API server and or the nodes or both publicly. It's more complicated to set up a VPN type mechanism to get into your nodes. It's much easier not to have it that way, right? As well as I've seen many clusters that were created using, like I have a cloud access, a cloud admin account, and I incorrectly set up my cluster and it is using Chris Love's cloud admin account. That's not good. Being able to have a Kubernetes cluster create a VPC or create other components isn't a great way to do security within Kubernetes. IAM, both authorization and both auth and auth-z are complicated enough. You don't want to add a layer where you're running your cluster as a Chris Love user.
I've set up a cluster. I went through my checklist, done all the things we talked about. Are there any either open source frameworks or testing tools that would run through and verify that the things that need access have and the things which should not have access cannot?
I believe the CNCF has a testing tool that goes through your cluster, soup to nuts, kind of gives it a once over. Also, frankly, the documentation on Kubernetes security on the Kubernetes site's tremendous. So I'm going through, it almost drills down in the same order that I've been using in a long time. And I can't say I've written any of the security documentation there, but it has a checklist of what to do. You've got tools that are owned or been donated and maintained by other companies that CNCF have. And there's plenty of companies there outside that can either help you set them up or test them after the fact.
Sounds great. I think we can move on to the next layer that you address, which is node security. What are some of the common attacks at the node level?
Again, it's instance or server level security. It's SSH attacks, right? Fortunately, our modern day cloud providers give us good authentication methods for SSH that is not username and password. But again, it goes back to you're maintaining nodes. I would say this, unless you're on data center, you're not looking at in-place upgrades. And if you're running in your own data center, you could be running virtualization as well. And if you're virtualized, again, you have your own cloud. We're looking at doing rollovers of an operating system to upgrade your OS. We're also looking at running immutable operating systems, which is another thing that I highly recommend. Running operating systems that have read-only components. It allows you to not have bad guys overwrite binaries. That's just a bad thing. But again, in terms of how Kubernetes upgrades, rather than upgrading your OS, you need to upgrade a node. So upgrade your nodes through a rolling upgrade, and then you update your operating system. If you're running on bare metal without virtualization, then most likely you are looking at in-place upgrades, but then you can shift around your workloads to do that. As we mentioned at the top of the show, OS level security is OS. It's really I would say that's probably the best known security posture that we know of, right? Because system admins have been maintaining OS level security since the beginning of time, at least the beginning of Unix and the beginning of computers. So that's probably the best known security layer or the best known security practices that we have. Now, as we move into the network security and we move into the pod security and we move into container security, I'd say those are all the newer technologies.
If I'm running on a cloud service provider, then they manage the nodes. They will auto-scale nodes in or out of the cluster as needed. Can I count on the cloud service provider to manage the node image and to refresh it if vulnerabilities are discovered? Or is that something that as a cluster operator, I need to push a button or do something when I want a refresh of the node image?
Really depends on how you set up your cluster. First off, you can run your own control plane for Kubernetes. Lots of companies that are a little bit more sophisticated do that. They'll still run their own master instances with etcd, et cetera, et cetera. So sometimes the control plane is maintained, sometimes it's not. I would say the majority of companies that are running on top of EKS and GCP or AKS, they are using a managed control plane. Nodes, on the other hand, you often have options that the cloud provider automatically upgrades for you, or you have to upgrade them yourselves. What companies are finding that it's often necessary for you to upgrade your nodes. Workloads are not typically, like you still have complicated workloads that are not, I'd say, cloud native friendly necessarily. And because of that, the upgrade process can have a couple bumps here and there. There's many companies that still have outages when they do upgrades. And you can't have a cloud provider automatically upgrade for you necessarily. Nice theoretical world, we'd be able to have that. There's other packages within cloud providers where the cloud providers are maintaining your nodes for you. And then, of course, upgrades do happen in the background. You're able to set up, here's the window. I want my upgrades to happen between 2 and 4 a.m. Eastern time on Saturdays, for instance, or on Tuesdays, because that's the lowest traffic day of the year or a week that you have. So again, there's options. Going back to what you're talking about originally, Robert, those are decisions you need to make before you set up your cluster. Do you want to maintain your own control plane? Please don't. Please don't, unless you really know what you're doing. Do you want to maintain your own node pools? 50-50 on that, depends on the amount of staff you have. Or do you want your cloud provider to completely maintain everything for you? And on top of that, then you're looking at less work, but you lose control. There's trade-offs there, definitely trade-offs.
Give some more details of what can go wrong during an upgrade. Theoretically, Kubernetes will reschedule traffic off of the nodes you want to remove and onto the new ones. But when does that not work as intended?
Long-running jobs, for instance, that don't restart. So stateful applications that aren't truly cloud native. You can run into problems with more complicated stateful applications during an upgrade process. You need to do something to the database, for instance, put it into a certain type of mode before you upgrade, before you evict the pod. So sometimes you've got to do 3 steps before you upgrade and then 3 steps after you upgrade. So that makes it a little bit more complicated. Older database systems that have been made more cloud friendly still have some challenges. So stateful applications, long running applications that don't necessarily restart themselves, or you have a 60-minute job, you go through an upgrade, shouldn't be upgrading at that time because those jobs are running. Now you've got to rerun a 60-minute job. And if it's a critical process, it's kind of challenging. And you can run not only in upgrades, but you can run the same thing when you're running or run into the same type of problem when you're running autoscaling. So if you have a long running job, such as a CI build, your autoscaler sizes down the node pool, which in effect is the same type of behavior you do when you upgrade a Kubernetes cluster. You'll have that job kicked off. Hopefully you want that job to restart, but sometimes they don't. From security perspective, the upgrade process is important that it goes quickly. so that you can remediate security issues quickly. If you're looking at redeploying workloads, you're looking at pushing out new workloads. It's a combination of the processes that you have in-house to run upgrades, how complicated your workload is, as well as if you need to roll out new workload. Say you've got a Spring dependency issue where there's a CVE in Spring and you need to roll out an entirely new application because of that, or 40 applications. Again, your CI needs to be able to handle that type of rollout.
I've been involved in database migrations some years ago. This typically involves a lot of runbooks, manual steps, like you described, where the 3 things you do before and the 3 things you do after. I am aware that there are some offerings in the database world where they've created Kubernetes operators that, to some extent, can take over the role of a human system admin. Are most things in Kubernetes world now aiming to be pretty automated in face of all kinds of disruptions, or is it still kind of old school where database is going to be migrated and we're going to have downtime and we're going to babysit it?
Well, it depends on what you're running, right? It's application and operator dependent, not necessarily Kubernetes cluster dependent, is the way I'd put it. If the workload can restart itself nicely, you flip a button, hey, I'm in fault tolerance mode, and you know that your fault tolerance works as expected, you should be fine. It's running the upgrade in dev first to make sure that you're fine, rather than having a 40-step runbook and playbook. Are we there yet? No. If you can afford it, have somebody else maintain your databases for you. Have people, like I would say, most companies aren't Google, aren't Apple, aren't Facebook, right? They don't have hundreds of engineers that maintain their databases for them necessarily. If you are that company, then yeah, you might be able to get away with it. The thing with running databases and other stateful applications is you have to understand how that stateful application actually runs on top of Kubernetes really well. It's not just I'm running an application and it runs great. It's I'm running an application on top of Kubernetes. Because of the way it fails over, and it says, okay, you got 60 seconds to leave application A, B, C, or replica ABC is a better way to put it. You have 60 seconds and you're out of here. I don't care what's going on. This node's going down and your PID is going to get terminated. So your application has to handle that. And realistically though, Robert, your application needs to handle that anyways, because it's the same pattern that happens during outages. Again, it goes back. If your company can afford RDS, why not use RDS? If your company can afford running SQL Server on Azure, let the experts handle it. It turns over some control. You have to run their version of Postgres rather than, you might have 3 versions of Postgres that you can run. So if you need a much older version, then you might be running it yourself. But that's a whole other story where let's have Postgres updated in your company. It goes back to time and money, right? The story I tell about security is you're going to get hacked most likely. You're big, you're going to get hacked, and or people are going to be knocking on your door a lot. But it goes back to business risk and time and money. As much as we talk about these security offerings and what to do, it all goes back to how many hours a day we have to engineer it, how many hands we have on keyboards. And I would say now we've definitely have some help from AI. I don't think it's quite there yet, but supposedly we're going to be out of a job here pretty soon, Robert. So I don't believe that, but that's a whole nother topic that we don't need to go into. But like I said, it's all time and money. We can do this. It's not rocket science. There is a broad range of things you need to look at. But it goes back to pretty much what we've been saying over its chat.
Would you accept one of the standard node images that's recommended by the cloud service vendor? Or would you start from a long-term or stable release of your favorite operating system and then batten down the hatches to get it even more secure than the off-the-shelf?
I would say use off-the-shelf. The reason being is that they have a staff of 100 people or more that are maintaining that image. What most companies, they're lucky if they have 2. Most companies don't have people that write kernel level code, and the cloud providers do. A good example, this happened a long time ago, was the issue with the Intel processors where we ran into some processor issues in CVEs within the operating system itself in the kernel. So the CVE was announced the day after Google released new images that contained the fixes. So we're talking virtually immediate. It took Debian and Ubuntu a couple weeks to catch up, if not longer. So you're looking at that type of lag with CVEs. where AWS, the big folks are talking about the CVEs before you even know about them, and they're coming out really, really fast with patches. RHEL is the same way. And I'm not saying there's anything wrong with Debian or Ubuntu or XYZ operating system. There's definitely folks that even offer operating systems that are built for Kubernetes nowadays. So do you need one? I don't know. Do you have a use case and is there business value for your company to have one? Great. Will I run on top of, I do work with images and I get frustrated that there are some CVEs running around in a couple distributions and they say, no, those aren't CVEs and we're not going to fix them. A lot of security people don't like that. But I go to Amazon Linux, for instance, and I know if I'm going to put something on Amazon Linux and get it screened, I would say about 90% of the time, if it's Amazon Linux maintained packages, it's going to pass screening. Same thing with, I forget the name of the operating system that GCP runs, which is completely immutable, by the way, which is pretty cool. And again, I can't even screen that in a lot of ways. But again, it's leveraging. You pay enough for a cloud provider as it is. Use their toys. Leverage their knowledge as much as you can in a wise way. If you have use cases where you have XYZ software that has to run at the node level and you have to have this, then I understand you got to run that specific operating system. But again, it's kind of like running your own email server nowadays, Robert, running your own image registry. Use the services that do it really, really well. Like, I don't want to run my own logging. I want to use somebody to ship my logs off to, and or a solution that's in-house that I ship my own logs off to. I don't want to do it myself. I haven't admin an email server in I don't know how long. We want to use the experts.
Let's switch topics now and move on to the next layer of your stack of the top security issues. That would be the network. What are the main issues in the network security area?
It's access. So within a Kubernetes cluster, any pod can access any other pod unless you set up network restrictions. You either want to use network policies or a service mesh like Istio. This is probably one of the areas that I see the least maturity in within the folks that I work with. I would say recently, I've seen far more maturity where folks are using service mesh that they want to use, or they're using network security policies where you are limited to call outside traffic. In other words, your pod cannot get to Google, as well as your replica A cannot get to a different namespace with replica B. And that's definitely something that you need to look at and control. And it's a lot of work, to be honest. Within a namespace, most pods will be able to talk to other pods. As well as, so there's two different ways that you can set up a pod in terms of which network it runs on. Because we have our host network, right? And it's how all the other hosts talk to each other. It's the typical networking pattern that we look at. Then we have some sort of pod network, whether it's virtual or it's IP'd a different way. They've done it about 15 different ways sideways. But if you run your pod on the host network, it can access everything in the host then, depending on the permissions you give it. So definitely keep your pods on the pod network. There are some daemon sets and controllers that do host level operations. For instance, you need NVIDIA drivers installed, right? There's daemon sets that will run on your host. So when your host starts, NVIDIA drivers get installed. So you have to run them on the host network. But if you can, and majority of your workloads should be on your pod network, as well as network traffic. I would talk about, you mentioned operators. Operators need to talk to the control plane, the API server. And because of that, you're looking at RBAC security. By default, don't mount the service account token, which allows for you to authenticate, or at times, if you misconfigure it, allows you to authenticate with the API server. So it's controlling access there. Also, you're looking at DNS as well. That's another consideration at a network layer. Everything basically within Kubernetes is all DNS. When you're talking to a service, that's DNS. When you're talking to another pod, that's DNS. And that's really, really important within a Kubernetes cluster itself. But yeah, one of the key things you can look at with intrusions is you go from pod to either a secret you shouldn't be able to get at, or you go from pod to your API server. Secrets is another thing we should discuss, Robert. If you want to throw that in the list, we can talk about that after we talk about networks. But there have been some really good improvements in keeping secrets secret, as it would be.
I want to go back through, you made a number of points there and to delve into them in a bit more detail. Network security policy controls which namespaces communicate with other namespaces, and service mesh is more granular. Mm-hmm. They are similar but different. Would you use one or both, and for what purpose each one?
Sure. Network service policies control both inbound and outbound traffic, right? Ingress and egress from a pod that the network security policy is bound to. So you can restrict talking to Docker.io from a pod level, or you can restrict Docker.io talking to the pod, or you can restrict pod A talking to replica B. You can do also all of that within Istio or whatever service mesh of the month you pick up. I'm not a service mesh expert. There are very valid use cases for service mesh, and there's one very good security use case is where you have all your traffic within your clusters encrypted. That's definitely a use case when you're looking at sensitive information that's traveling in between pods. If you're not using encrypted like your application doesn't support encrypted transmission across network layers, you're looking at all your network traffic's unencrypted. So you have a PHP, a web application that makes authentication to a job engine within your cluster and it's password protected. That password is going over the wire. But if you have Istio installed, right, that password's now encrypted, or another service mesh, of course. So it's using, that's one of the things. This is drop-in, right? That's one of the huge benefits you get. I'm not a service mesh expert. I have other good friends that are really good with that stuff. There's definitely use cases, but once again, you're either paying for somebody to maintain a service mesh for you, which is yet another application. You're looking at more load on your system. The CNI provider that is installed provides your network security policies. So you're really not looking as much overhead, compared to running a service mesh. And there's actually quite a bit of overhead nowadays running service meshes. Still is. It's getting a lot better than it was initially. And upgrade challenges as well with service mesh. And, you run another application, Robert, right? You get CVEs in it. So try to limit the number of applications you're running. So, you're limiting the number of entry points you have from a security standard.
I'll let our listeners know that we did episode 600 on service mesh. Chris, now back to our conversation. You mentioned that the operator needs to be able to access the API, and so it needs RBAC, whereas most applications you're running do not need the API. Then would you default to the average pod should not have any access at all to the API and therefore should not have any credentials available? I think I'm just, at this point, restating what you said. Do you have anything to add to that?
Well, it's on by default is what I have to add. And I've had conversations with security folks before about that have coded it. And that look your dog gives you when it kind of turns your head and goes, huh? That's the kind of look I often have where the service account token is automatically mounted. So that's not something you want. Now, that is also a pod by default will use the service account for the namespace. So again, create a service account like most Helm charts, or you create your own deployments by hand, will have service accounts. Like you'll want to create your own service account. So there's really two things, right? Does it have a service account token? What group and or permissions does that service account token have? And are you restricting, even if you mount the service account token, for instance, if you don't allow a pod to talk to the API server, you remove that path using network security policy. Doesn't matter if it has a security token, but don't mount it. It's a bad thing if you don't need it. And let's look back to operators to give a little bit more color to that. Typically, operators create pods, maintain them, need to be able to access pods, do other cool things with pods. So they require access to the API server in order to do that. In essence, they're making kube control calls, if you want to think about it in that way. And that's how they maintain, say, you're running Cockroach database. Worked with them on their operator, actually, funny enough.
We did another entire episode, so number 634, about Kyverno, which is a policy as code layer that enables you to create policies for things like every pod must have a non-default service account, or many of these things that you are recommending could be turned into a policy. Do you have a view about Kyverno or tools like that and where they have their place in your overall security profile?
Sure. And I assume that Kyverno is an admission controller?
So you have a policy as code, which is just a text file, and it goes in a config map and it integrates with the controllers to enforce the policies on, I believe, on every single API call.
Sure. And that's actually, so I mentioned PSPs, right? Pod security policies. They now have a pod security admission controller. And that's most likely the pattern that they're using for that component as well. Yes, I do recommend that because, for instance, I never recommend running a Docker image out of Docker Hub, right? You want to, if you're a big enough company, you want to be able to screen the bash image that you need to run within your system. So what an admission controller can say is you need your own unique service account for this deployment. You need to use the unique service account for this namespace. You cannot launch a pod that contains an image from docker.io without an admission controller. Like it's kind of two ways, right? You should be screening your YAML before it's installed in Kubernetes. And then you should be screening your YAML once it's running in Kubernetes. Because you can, somebody can come in, bad actor can come in, get kube control access, edit the YAML on a deployment, and then it fires up their own image. Well, if your network policy doesn't allow you to download an image except for an image inside your system, from ECR or Docker, whatever Docker registry of the month you're using or container registry, then you prevent these things. But again, admission controller is really good. It's a lot of maturity though. I've worked with a lot of larger companies that don't have security admission controllers. I would say that is probably one of the most mature, like if you're looking at people that are crawling, walking, or running, that's definitely with the people that are running with security. They're running their admission controllers. The pod security admission controller now is part of Kubernetes. And that it goes back to the statement you've made. What have they tried to make simpler? It gives you 3 stock out of the box profiles you can run with your workloads that enforces these types of things that you mentioned, Robert. So, and I'm sure, the tool that you mentioned earlier as well provides some out of the box configurations and some best practices. Again, it goes back to leveraging folks that know what they're doing. I'm not going to write my own container screener. I'm going to use somebody else's, whether it's open source or closed source. I've got enough going on in my life. Most engineers got enough going on their life. We don't want to maintain some one-off awesome tool.
Do you have any stories come to mind of a network security issue that you either debugged or found doing an audit of somebody else's system?
Oh, no, this happened to one of our systems, a client that I was working with. And this goes back to admission controllers, which is don't allow external services to be launched if it doesn't need to be launched, right? Only route your traffic through ingress. A engineer, and he was one of the DevOps engineers, for some reason launched a Juniper pod, Juniper Networks, big data science stuff, right? Launched one of those, a deployment, had it on an external IP address. I think 30 minutes later, a Bitcoin miner was installed on it because people are going through IP addresses on the cloud provider that we were on. They look for, okay, this is Juniper Notebook, right? They hit the path where you get the login screen. Then they say, okay, I'm going to try these 15 exploits on the 15 different versions. We had one of the versions that had an exploit in it. 30 minutes later, we had Bitcoin miners installed. Our CPU usage went up just a little bit. So again, how could that have been avoided? One, use a mission controller or network security policies where a pod cannot download software, right? If you don't allow a pod to talk to external networks, why should a pod be able to talk to, Docker Hub? Why should a pod be able to talk to Google? Why should a pod be able to talk to XYZ FTP site? Shouldn't. So if you don't allow that traffic, if you don't allow a pod to start up with a image that is a foreign image, pod won't even start, right? So you won't run into that problem. If you don't have a set of base images that you're constantly screening for, in other words, you can only run company, Acme's Python image when you're running a Python application. If you allow any Python image, you're going to get CVEs in-house. And it's really tempting to do that. it's really tempting to go to Docker Hub and use Python Slim 312. Great product, by the way. I'm not knocking them at all, but I know, for instance, it won't pass CVE screening.
Love that story, Chris. Let's move on to the next layer in the stack, which we inserted in the middle of the show, secrets. What are your main points within secret security, and what's gotten better in that area?
So back in the day, secrets weren't secrets, and they're still not if you use default secrets. It's base 64 encoded or base, I forget exactly which encoding they use on it, but it's plain text, But now most cloud providers and some folks within on-prem allow you to mount so you have a cloud provider secret. Kubernetes allows you to mount that secret as a volume. So you're on the operating system. It's actually a mount point on your container. And that's how the secret is either injected or becomes a file store. It's typically a file level secret that you can then access with your application. That's probably the slickest. And it's the same type of spec where we have different like CSI, CNI, all the different file providers. Well, now we have a container file provider reference. Like I said, Amazon provides it, Google provides it. I'm sure Azure provides it as well. So all the big providers are using that pattern now. And still, your secrets, in clear text, you crack into the pod level, you'll have access to it, right? But pod replica A cannot talk to secret C that it shouldn't be talking to and access it, right? You're not able to start a pod and mount any secret now. This pod has to have this profile and be able to access this secret. And it goes back to, pod identity within the cloud. So for instance, say your pod is accessing the cloud components, right? Often CI needs to download images. It needs to push images into registries. So again, it goes back to secrets management. You don't want to put a cloud level admin, I can push into ECR password in a regular password. You want to use pod identity management, which binds a cloud role to a pod itself. You then authenticate with that pod role. So it's a couple of different things. You need to have your GitHub token or your token for XYZ SaaS that your application talks to. You put that into your cloud provider secret. You can then easily roll it. There's sessions. It can be refreshed. Then you put it in through a file system mounted secret, as well as if you're accessing your local cloud provider, you want to use a role on the pod and authenticate in that manner rather than accessing a secret out of a plain text secret. Everybody is using encryption at rest. So within etcd and within control plane, all the secrets are now encrypted, especially if you're using, what I recommend is the cloud providers maintaining your control plane. You're not running etcd yourself. That's the big gotcha. I'm glad that improved. But, with the improvements, it became a little bit trickier. And getting pod level identities running correctly it's a little bit more fun. So you not only have to understand Kubernetes, it's kind of like wiring, it's a Russian doll, right? You've got one egg that needs to fit inside another egg that needs to fit inside another egg. Then you have your secret mounted correctly.
Yeah, that Russian doll thing, that's totally how I feel about Kubernetes. Now, this last point, I wanted to go through it because it's a little bit complicated to make sure I got all the pieces. Say I'm trying to access a service through the cloud provider, which might be, for example, ECR. There may be an option to have password authentication, and you could put the password in a secret and mount it onto the pod. What you're saying is don't do that. Create an identity within the cloud service provider and assign it a role that has a policy that grants it access to ECR, and then bind that identity to your pod. So it's happening now. There's still some token, but it's outside of the pod. So if somebody gets into the pod, they can't really easily get the credential. Did I get that right?
You got most of it right.
Okay.
So let's go there. It's actually not, it still is a token within the pod, but it's a role that exists in your cloud provider. You don't have the username and password inside of a secret. It's not clear text, right? There's a token that is mounted again inside the pod, and that's where your credentials exist. And that's controlled by your cloud provider. So you don't have to worry about 15 different points accessing that same password. Pod A has service account A. That service account has an annotation on it that includes the role binding. Because that exists and because there's an operator or controller that runs inside your, cloud instance of EKS, say, it realizes, okay, this annotation exists on this service account exists to this pod. I mount this token, this AWS authentication token within the pod when it starts. You can now use AWS CLI and you have the role. So I create foo role in AIM. I give it this grant, which is list ECR images in this repo and this account only. I then have fine-grained control over where it's talking. It's the same thing, right? I have to maintain those IAM roles somewhere, but now it actually exists. The source of truth is the cloud rather than the source of truth being, it's a cloud. Oh yeah, I got to have a password too that I got to go change. For instance, you can automatically set it up that it has to roll. Like it will reset itself. You don't have to go through and reset stuff.
Sure. We would like credentials to be short-lived. Does this mean we all need to be coding our services or using libraries which either get some kind of a notification if a secret changes underneath and refresh, or reread it from the file system every few minutes to ensure that we're always using the latest?
And that's the DNS controller that runs within Kubernetes. Actually, it's not the DNS controller. I forget which one it is, but it has a config map mounted to it, and it deliberately refreshes that config map. So that's the type of pattern that you're talking about where, hey, did my metadata data get updated? Yes. But the thing is, with most cloud libraries, at least, they do that refresh automatically, right? If you're using a web token in AWS with their API, they understand it refreshes. But yes, it is a short-lived token. It is session-based. There is a duration on it. So yes, you do have to refresh it. But, again, I've even seen libraries that allow authentication from a database into a cloud database that uniquely binds into the pod identity. So yes, you have to be aware of it. As a cloud native application engineer, this is the same type of thing that you have to think about as the fact that you've got to understand you're going to restart, you're going to leave your server at within 60 seconds. That's the type of application that you want to design. You want to be fairly stateless. And it goes back to that. If you're you're running a long job for CI, you've got 60-minute job, your session token is for 30 minutes. Guess what? Halfway through, you better check to make sure your session token is active before you try again, right?
Absolutely. The last major area we're going to hit, possibly two areas, container and pod security. Is that one or two distinct topics, Chris?
They're really two different distinct topics. Pod security, and we've already been covering a bit of pod security because you brought up the service account token. We talked about RBAC. That's directly integrated into whether you run a stateful set, a deployment, a job, a pod, whether you're mounting that. And we talked about pod security when we're talking about choosing which network the pod runs on top of. That's yet another configuration, whether it's a host network or pod network. It's actually in a deployment or a pod YAML. So we've already been talking about a bunch of that. What we haven't talked about are specialized pods. Some pods you want to be able to run, for instance, system level Linux commands. If you're installing NVIDIA drivers with XYZ pod, that pod is going to have run the host network. It's also going to have specific capabilities through your container engine that you're running, .run C, whatever you're running to run your images. You actually define those Unix level permissions within the pod. Also, you can look at stuff like SE Linux, and you can look at AppArmor. All of that can be derived through the newer pod security and mission controller. So now that kind of stuff, you want to talk about, again, people that are crawling, walking, running. That's like sprinting, right? I know of very few people, at least I've run into very few people that are running AppArmor profiles, for instance. But if you're you know that your workloads are going to be attacked. Your Nginx servers are going to be attacked on a fairly, strong basis. Might not be a bad idea to look up how to run AppArmor for Nginx. That way, your workload is isolated better.
I did some reading on this area, which discussed a technique where pods are granted temporarily the ability to perform operations at root level, and even then only to a subset of system calls.
Right.
Could you go into more, what's that about and how to use it?
So that's actually just low-level Linux stuff. It's been around forever. What you're talking about now is we're granting, so at a Linux kernel level, a process is, you brought up root, right? You should never run your pod as root. So within, and that's another configuration within Kubernetes, is whether you run your process within your container as which user. You should always use a different user. If you run as root, you also want to see what permissions, like sometimes I've known controllers that restart nodes. Kind of crazy, but there's use cases for it, right? Back in the day, I know folks over at Comcast were mounting 2 different video cards to a node, and it would require a restart at times because this is actually a physical video card. When they're streaming and encrypting movies, you would be talking to an actual video card that would be streaming you that movie. I'm sure it's changed a bit over the years, but restarting, there are use cases. That's actually one of the Linux level permissions, whether you have permission to restart Linux. So again, you're able to do that fine grain type of specification within a pod on what type of permissions it has. And goes back to don't run as root within a container, but that's both pod configurations as well as container configurations. So don't, and there's a lot of people that are a lot better experts than I am when it comes to container level security because that's such a broad topic now. But there's just some basics, as well with container level security. But yeah, you're able to go through, do AppArmor profiles, SE Linux profiles. There's a lot of fine tuning you can do to isolate your workloads and specify the workloads that are given elevated permissions are controlled with only the elevated permissions they need.
In the short amount that we have left, I'd like to do a couple of quick hits on container security. We did already discuss some issues around containers, such as whether they contain known vulnerabilities, where you get them from, who can pull them down. One other issue I had in my outline is the idea of container escape into the host. How big of a problem is that, and what can you do about it?
Don't run a host network. So if you're not on the host network, the capability to escape to the host reduces tremendously because of how the networking and the virtualization, almost quasi-virtualization works. The routing isn't there. So that's it. Also, there's some container systems provide the capability of isolating the workloads, as well as if you have workloads, you can isolate workloads to run on specific nodes. So if you do get to the host, you don't, like say you have workload A that cannot talk to workload B. It just can't happen, right? So don't put workload A on the same nodes that workload B is on. Pretty simple. I knew of a bank that every application had its own Kubernetes cluster. Really interesting pattern. Not a bad thing. If you need to isolate your workloads at such a low level, then possibly look at that. There's also Kubernetes virtualization within Kubernetes now, where you can run a Kubernetes cluster inside of Kubernetes because that's multi-homing. But I've digressed. Let's go back to image level security and container security. Upgrade. Have the capability where you run CI and CD often. Have a set of base images. If your shop works in Python, works in Go, works in Java, have base images for your developers. Have your golden Java image, have your golden Python image, have those screened on a regular basis, have those upgraded on a regular basis. It's really important. I go into large companies and people are still not screening their images. They screen their operating systems, so goodness gracious, their nodes are being screened, but Bash inside of an image isn't being screened. Also, don't install Bash if you don't need it. Don't install Whois if you don't need it, right? For instance, Golang is one of the neat languages where you can compile and have it run on virtually nothing. The less binaries that are in an image, use it. Use multi-layer images for your builds, right? So you have a build image where you have your, libraries that your shared build libraries that you need for Python dependencies. But in the next image that you're actually deploying into production and using, don't have those libraries in it. Don't have Git installed. Don't have curl installed. Don't have, wget installed. Just don't. right? But sometimes you have images, CI is probably the worst, right? Because CI images need to, for instance, talk to GitHub. They need to do XYZ. They need to do all these different things. So be rigorous about maintaining your own images and in upgrades. Don't run images as root, as we mentioned. Don't allow your images to do a lot. It should be run application. That's it. If you, run Python 3.12 when you have time, and make sure that you have a backlog to upgrade to Python 3.13. There's a reason that you want to keep upgrading. Also, have it simple as possible to redeploy your entire stack. It's good for DR, but it's also good when there's a huge bug that comes out that allows to do remote execution, and you run that library everywhere. Log4j comes to mind. You've got to be able to push a button and as quickly as possible, redeploy your entire stack. Kubernetes is really good for allowing you to do that. Don't get me wrong, but it's still, down to other principles, which is your CI and CD system. Make sure that that's tuned in so you can do it. And the way you get to do that more often is upgrading often, right? So if you're upgrading regularly, you can redeploy your workloads regularly as well.
We've hit on some pretty big mountains in the landscape of Kubernetes security, Chris. In time that we have left to wrap up, is there any parting words you'd like the listeners to have of top 3 things to think about in securing your Kubernetes cluster?
Upgrades, protect your control plane, and step back and make sure you do what you can when you set up your cluster initially. Those are probably the 3 things. Upgrade your nodes, keep up to date. I've walked into environments where they're running a control plane that isn't even supported anymore. It's so old. It's over a year old. And gosh, that ain't that old, right? But over a year old Kubernetes might not be supported anymore, depending on what version you rolled out at that time. Upgrade your Python. Upgrade, if you got Bash in your image, upgrade it. And as well as, and we really haven't talked about this, but there's other systems where you've got Apple level security you got to be concerned about. You've got Kubernetes level security. You've got intrusion detection. All of that matters if you're at the level of organization where you've got the time, staffing, and money to do that type of work. It's a pretty broad topic. And leverage experts, right? There's a reason I run Kubernetes. It's written by people that are a lot smarter than me, and I realize that I'm not the one that's going to go write the latest AI tool because that's just not my expertise. I go back to I'm a building, kind of a construction engineer for computers. I'll build a cool place that cool applications can run on top of. But in order to do that, I've got to have some groundwork. I've got to have some base layers. I've got to have some base systems that will support me. And it kind of goes back to a DevSecOps or DevOps principle where we need to automate stuff. It keeps me out of trouble. Where
can listeners find your book, Core Kubernetes?
It's available on the Manning's website. You just, go to manning.com and type in Core Kubernetes. Really want to thank Jay for dragging me in to write a book. It was quite an experience. It would take a lot for me to write another book. As well as, they can find me on Chris Love CNM on all the different socials.
Any other place on the internet you'd like to point people to?
Sure. A wonderful company I work for, which is modernize.io. Love working there. It's been a real blessing. We're a consulting company. Think of us as a boutique version of Deloitte, as you would say. And, really happy to join you here today, Robert. Appreciate the time and the great questions you've asked me today.
Thank you, Chris. It's been a pleasure. Thank you for speaking to Software Engineering Radio. And for Software Engineering Radio, this has been Robert Blumen. Thank you for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.